All right, we're going to try to do some of the exercises in 1.2 that people had trouble with. 1 was one of them, and I started this and then got interrupted, so let's look at this here. The limit as x approaches -1. So we're going to try to go in towards -1, which is right here. And we're going to be on the curve because we want to know the y height as x gets close to -1, and the height goes towards this value, which is, if that's 2, that's 4, that's 6, and that's where I got the 6. Now let's look at the y height as x gets close to 0. So as we get close to 0, the y height goes towards, if that's 6 and that's 8, that looks like about 7. And both sides go to 7. And the y height as x gets close to 1. Well, as we go towards 1, this one is headed towards 6, but this one's headed towards -2, -4, -6, -8. So we have a left-hand limit of 6, a right-hand limit of -1, so there's no limit. The left and right have to be the same to have a limit. So the limit does not exist is what they write. They write does not exist. Okay. At 4, there's the values down here at -4, but what's the limit? So we come in from the left, it looks like it's approaching 2. Come from the right, it looks like it's approaching 2. So the left and right both go towards a depth of -2, and so the limit is -2. That was number 1 that some people struggled with. And then number 5, some people struggled with. And it says, consider this function. And it says, what's the domain of, let me write this bigger for the video here, 16 minus x to the 4th over x squared minus 4. Well, a rational function where two polynomials divided, the denominator can't be 0, and that would happen at 2 and -2, so this will be all reals except, that's a double stemmed at R, all reals except 2 or -2. And there's other ways to write that, but that's the idea. Use a sequence of values near 2 to estimate the limit. So I would put into this like 2.1, 2.01, 2.001. And so I pull out my calculator to do that. Let's see, I was just using it, I think. Calculator, where'd you go? Here we go. So I got to type this function in. So I have a numerator of 16 minus x squared, 16 minus x squared divided by the quantity x squared minus 4, close parenthesis, and we're going to put numbers in. So I've got table set on ask, not on auto on ask on the dependent, but independent ask, so that it will actually calculate it, and I'm supposed to get close to 2. So not to 0 as that one did. So I'm going to try 2.1 and then 2.01 and then 2.001, and it looks like it's getting, oop. Huh. A near 2. Did I type this in right? Oh, I forgot to put x to the 4th. I didn't recognize these answers. My mistake. X to the 4th. 16 minus x to the 4th. Okay, now let's go to the table. And it looks like it's getting closer and closer to 8. And if we come in from the other side, 1.9, 1.99, 1.999. Looks like it's getting closer and closer to negative 8. So, as I get closer and closer to 2, it looks like it's coming out to be negative 8. And it does exist because coming in from both the positive side and the negative side, from the right and from the left, I get same value of negative 8. Use algebra to simplify that. So, and hence evaluate the limit as there. So if I take that, the 16 minus x squared, and factor it, that would factor to 4 plus x squared and 4 minus x squared over x squared minus 4. This denominator is almost like this. I'd have to take a minus 1, factor out a minus 1. This could be minus 4 plus x squared if I take times a negative 1. So negative 1 times minus 4 is plus 4. Negative 1 times x squared is minus x squared. So I could replace this with that, and that is the same as this, a minus 4 and a plus x squared, so they would cancel. So this function is similar, not identical, but similar to negative 1 times 4 plus x squared. And when that gets close to 2, 4 plus 2 squared, 4, is 8, and negative 1, so it's negative 8. So this is the algebra they wanted us to simplify, and then to take the limit as x gets close to 2 on this, we get the negative 8. Discuss how your findings compare to your result in B. They're telling us the same thing. It's negative 8 in the limit. Okay? And then, true or false? Does this function equal that one? Is this equal to, oops, sorry, it's off the screen. Does this one equal this? And the answer is no. This one can't use 2 or negative 2 in it. This one you can. So this function is similar to this one, but not equal. The next question is, based on all your work here, draw an accurate graph from 1 to 3. No, you can do that on a calculator, so I'm not too worried about that. Okay? 6. What is the domain of this? Well, it's all reals, except you can't use, in this, let me write it larger, if x was negative 3, we'd have division by 0, so we can't use x equal negative 3. So all reals except negative 3. What is a sequence of values? Use a sequence of values near negative 3 to estimate the limit at negative 3. So we go to our calculator and we type in this equation, and on the older calculators it would be ABS. On the new calculators it actually does a nice thing, math, number, absolute value. On the old calculators it would write ABS parenthesis, and you would type the stuff in and close the parenthesis. Here we have, what was it, minus, oh, I forgot the minus out front, so I go back and go second insert and put a negative in there. And I get it where it's not reflecting. I'm having trouble. Where's the place? Maybe I'll turn that off. Did that help? Nope, so turn it back on. Okay, absolute value of, what was it? X plus 3. X plus 3 divided by the quantity x plus 3. Close parenthesis. And we're supposed to try stuff near negative 3. So I'm going to go to second table, and I got to get close to negative 3. Please look better here. Okay. So I'm going to put in negative 3 on negative 2.9, negative 2.99, negative 2.999, and I'm getting closer to negative 3, and I'm getting negative 1s. Now I'm going to do something from the other side, from the left side, lower. So I'm going to try negative 3.1, negative 3.01, negative 3.001. So from the right side, from bigger than negative 3, I'm getting negative 1s. And from the left side, or from the smaller side, I'm getting 1s. So explain, estimate the value of the limit. Well, there's a left limit of 1 and a right limit of negative 1. Does the limit exist? No, because the left limit does not equal the right limit. The limit of g of x as x approaches negative 3 from the plus side does not equal the limit as x approaches 3 from the left side of g of x. The right side we were getting negative 1, and from the left side we were getting 1. The left and right are not equal, therefore there's no limit. Okay? All right. True or false? G of minus 3 is minus 1. If I put negative 3 in there, I get 0. Put negative 3 in there, I get 0. So what's the value? I can't put in negative 3. So g of negative 3 equal minus 1? No, it's not defined at negative 3. Can't use negative 3, so no. False. You can't use negative 3. True or false? This whole thing is negative 1. False. It's sometimes negative 1. For certain x's it's negative 1, and for other ones it's plus 1. Okay? And F. Based on your work above, construct an accurate labeled graph of this. So this thing looks like 1 when we come from the negative side. Let's go over here. As we come from the negative side, it's 1. When we get to negative 3, all of a sudden it jumps to negative 1. And they said just on the interval from minus 4 to minus 2, so they meant just draw this part and this part, but I'm doing more. But at minus 3, we can't use it, so those are open circles. And that's the idea for that one. Okay, 7. For each of the following prompts, sketch a graph on the provided axis that has the appropriate stated things. So we've got to do these things on the graph. So now I've got to tear this sheet out, fold this over. Well, maybe I should fold it the other way. And put it under my graph so I can look at those rules and make the graph. Okay. F of minus 2 is 2. f of minus 2. So the y height, the height of the function, the value of the function at minus 2 is 2. So when x is minus 2, we're at 1, 2. So that satisfies this one. The limit as x approaches minus 2 of the function is 1. So as we approach minus 2, the function's height, the height of the function, is 1. So if we approach minus 2, we're supposed to head towards a height of 1. But we already know it's not there. It's up at 2. But it has to approach this, somehow come towards this, either from the bottom or the top, from up above or down below or whatever. So, but it goes towards there, but the height is 2. At minus 1, it has a height of 3. And the height, as we get close to minus 1, is also 3. The height approaches 3. So from the left and right, it approaches a height of 3. So that works for just going towards it. At f of 1, there is no value. So there's either a circle or a hole. It never touches this place, this whole vertical line. But as we get close to it, it approaches a height coming in from either the left or right towards 1. We're supposed to have a height of 0. So we get a height of 0, but there is no value, so there's a hole. As we get close to 1, it approaches this height of 0. It could go up, it could go down, or it could come up or come down, but it has to go towards this from both sides. And at 2, it has a height of 1, so there is a point there. The height of the function, the y value, the height of the y value at 2 is 1. As we approach 2 from either side, we have no limit. Well, we have no limit if it doesn't head towards the same value from the left and right. So I can make it come to at this point from this side and just leave at a different height. And then we have to go to there, and we have to come out of here. So it has a value of, at minus 2, it has a value of 2, but it approaches a height of 1 as we get close to minus 2. At minus 1, it has a value of 3, and it has, coming to either side, it has a value of 3. At 1, it doesn't have a value. That's why an open circle. But if you come in either way towards 1, we get a height of 0, 0, 0. And as we go towards, when x gets close to 2, the height goes to 1, so we have a solid dot there. But when we come from the left and right, we don't get the same value. We get a value here and a here. They're not the same, so there is no limit. Okay? And now, pull this down over here, and we have to do it again. There's a point. The height of g at minus 2 is 3. The height at minus 2 is 3. The height at minus 1 is minus 1. The height at 1 is minus 2. The height at 2 is 3. I've done those. At minus 2, at minus 2 and at minus 1 and at 1 and at 2, g has a limit, and it is equal to the value of the function at those points. So this one goes towards that one, it goes towards this one, it goes towards this one, and it goes towards this one from both sides. G of 0 is not defined, so this function doesn't exist on the y-axis. When x is 0, there's no y value. Y at 0 is not defined. The limit as we get close to 0, as x gets close to 0, the y values, the limit doesn't exist. So it goes from here to here. It goes towards the y-axis. We've got to get down here. I don't want to go too far away, so I'll just start turning, but it doesn't, there is no value here. And to make it not have a limit, we may want to jump. And no value here, and go on. So it doesn't have a value at 0, and it doesn't have a limit because the left and right are different. And then it goes on, gets up to here. That's a possibility. Number 8. Last one on this one. Okay. So we got this bungee jumping equation. I'll write it bigger here. 100 cosine of 0.75 t e to the negative 0.2 t plus 100. Okay. Write an expression for the average velocity of the bungee jumper over the interval 1 and 1 plus h. So we find y2 minus y1 over x2 minus x1. At y2, if that's the x value, we put that in for the x, or in this case t, the independent variable. We write 100 cosine 0.75 t is 1 plus h, close parentheses, e to the 0.02 t is going to be 1 plus h minus, plus 100, forgot the plus 100, all of this minus the height at 1, so all of this again with 1 in for the t's. So that would be parenthesis 100 cosine of 0.75 times 1 e to the negative 0.2 times 1 plus 100. Okay, there's, that over h, change in y over the change in the x's. The difference between 1 and 1 plus h is h. And then you would use technology, and I'm going to do a shortcut for this. So turn it on, and I'm going to do a shortcut. So the function, I'm going to clear this just so in case you want to use the shortcut. I'm going to write in the original function, 100 cosine 0.75 x, because the calculator uses x instead of t as the variable, close parenthesis, e to the negative 0.2 x, finish the exponent, plus 100. Now what we wanted to write, I'm just going to set that off to the side, turn that one off so it doesn't do anything with that. Then I'm going to come down and I'm going to type in this with 1 plus x in place of the x. It's supposed to be 1 plus h, but I'm going to make the x in this one be, the h in this one be x. So I'm going to write this whole equation, y1, which you get by going to vars, y variables, function variables, enter y1 with parentheses using 1 plus x in it minus the y variable, y1 again, so vars, variable, function, y1 in it, and this time I'm just going to use regular regular 1 in it, so I'm going to go parenthesis 1, close parenthesis, and then all of this, so I have to put parentheses around it, so I got to come back here and do second insert and put in a parenthesis. And then I got to go to the end and put a parenthesis. So that's my numerator divided by the x I'm doing here. So the calculator automatically puts 1 plus x in place of that x and that x for this first one, and then it'll put 1 in for those two. So this is a short way of putting all of that in. And now I can put things close to 0 because the h is supposed to go to 0, but my h is an x, so I'm just going to go to the table and put things close to 0. Close to 0 would be something like 0.1, 0.01, 0.001, 0.0001, and looks like I'm getting about negative 53.9-ish, 0.84-ish. Let's go from the other side. That would be negative 0.1, negative 0.01, negative 0.001, negative 0.0001. It looks like I'm getting about negative 53.84. I could also graph it, and we don't see anything, but we kind of know why, because it's at negative 53. Oh, it's headed down there. So I'm going to go to my window. Yep, but it finished graphing. Now try window, and I need to look down, so my y minimum's got to be a lot smaller, like negative 60. And now let's take a look at it. And we want to know what it is at 0. So I can trace near 0. At 0, there is no value. You can't put 0 in there because it's division by 0. But near it, I get negative 54 on that side and negative 53 on that side. If I were to go right there and go zoom in, let's see, it's going to zoom in there. I don't want it to zoom in there. I want it to zoom in down here. Enter. Taking its time. And then I'm going to go trace, and I'm going to go this side close to 0. I get negative 53.6. On the other side, you get negative 54. I could zoom in again, zoom to, right, I'm interested in right about there. And you can see on trace, and at negative 0.006 it's 53.79, and on the other side it's 53.88, and I could keep zooming in and get even closer and closer just looking at the graph. Okay? And what's the meaning of the value of the limit? So this is what this tends to. We found the change in these over this. This is the slope function close to 1. So this is, and S is the height that this person is, so it's feet per, and 1 is in, the H is in time, so that was in second. So at 1 second, this bungee jumper is going down at a velocity of negative 53.84 feet per second. That's the meaning. Okay,